a game that was created in 1972. In today's video, I will be creating my own Pong game using C++ and the SDL library for graphics. Now without further ado, let's go ahead and get into this video. In a previous video that I posted on my channel, I worked with the SDL library before to create graphics for my sorting visualizer. In today's video, I'll be doing the same with creating the graphics for the Pong game. So the first thing I have to do is create the project. Now that we have our project created, we can now configure the SDL library.
Here we go.
There are three basic objects in our Pong game. Two are the paddles in which to hit the actual Pong, and the other being the Pong. So using the SDL library, we have to create two rectangles and a circle for the objects of the Pong game. After creating the main.cpp file, where I'll be running all the methods and functionality of the Pong game, I next created the paddle.h file. Header files allow you to separate definitions from implementations, making code easier to read, understand, and maintain. In my last video when I created the sorting visualizer, I created all my functions in the main class, which is horrible for readability and scalability. So instead, to avoid this, I want to use object-oriented programming. There are four pillars in OOPs: encapsulation, abstraction, inheritance, and polymorphism. Encapsulation is a concept of hiding the internal data of an object. The only way to access the data is through methods mainly called setters and getters. Abstraction is a process of simplifying complex systems by breaking them down into simpler processes. In our case, we can make a paddle class, a ball class, and a game class, with each class solving a specific need, which can be a lot easier to work with compared to creating an entire Pong game in one go. Inheritance. Unlike the previous OOP concepts in this project, I won't be using inheritance. However, in the case of the Pong game, if I wanted to create a different type of paddle or Pong, then I can inherit the basic principles from the previous methods that I built and add different features to them. This can come in handy if I wanted to create power-ups that can change the way the paddles or the Pong behaves. And finally, we have polymorphism. This concept allows you to use a child class where a parent class is expected. For example, if we have a parent class called game object, and inside game object we have a child class called paddle and ball. Let's say we have a function called render game objects. We can pass a pointer to paddle or ball object to the render game object function, even though it's expecting the game object point. So to put it simply, polymorphism allows us to use different types of object in the same way. Okay, all that explaining to say that I'll be using object-oriented programming in this project because they offer a lot of advantages. Here's the paddle.h code, which consists of my paddle declaration, constructors, destructors, methods, and private data members. And here's the code for my paddle.cpp file, which provides the implementation of the member functions that I declared in the previous paddle.h file. Now let's run the code and see how it looks. Okay, next let's figure out a way to allow the paddle to move. So I added this line of code here. Drum roll please.
That one right there made me the greatest player of all time.
For so many reasons.
Okay, so I got the paddle to move, but there's one problem. To solve the problem of the paddle moving out of the screen, we have to make bounds for the paddle. In order to do this, we first take the height of the window, which in my case I set it to 600. And the reason why we don't care about the width is because obviously the paddle can only move up and down. Next, I created a simple if-else statement. It's basically saying if the paddle has moved further than the top of the screen, then move it back to the toppest possible point of the screen. The next line checks to see if the paddle is further down than the difference of the window height and the height of the paddle represented by window height minus rect.h, which basically does the same thing as the previous if-else statement. However, it checks to see if the paddle has moved past the bottom point of the screen. Now let's see if it works. To create a second paddle is super easy. All I have to do is create a second paddle object in the main function. Finally, I created the ball. Creating the ball was extremely easy. However, creating the movement of the ball to be more specific was extremely difficult. While most games, especially 3D ones, collision detection can be extremely complicated. Thankfully for us, we're going to be working on a 2D game form. In our Pong game, everything is aligned to axes. The side of the paddles and the side of the ball are parallel with either the X or Y axis. So to detect a collision between the ball and the paddles, we're going to be using the separating axis theorem. To put it simply, the separating axis theorem says if you can show the projection of two objects onto an axis and show that they have a gap, the objects are not colliding. If you're interested in learning about the math that goes into this theorem, I'll link the article down in the description. So basically, we want to cast a shadow from each object to each axis. So if we find a single axis where the projections do not touch, we can say the objects are not colliding. Now I'm completely oversimplifying this because this is extremely confusing, which makes you think how people in the 1970s were coming up with this kind of stuff. But anyways, with that done, that basically concludes the creation of the Pong game. Now let's see how it plays. Alright guys, that's gonna wrap up this video for today. If you guys like videos like this, go ahead and leave me a like. If you guys have any questions, feel free to ask them in the comments below. And until next time.